Okay, so now let's look at the example of the question. Okay, so if you read the question, for sheep, normal fur is controlled by a dominant allele, capital R, while non-uniform fur is controlled by a recessive allele, small r. So in a population of 2,000 sheep that mate randomly, it is found that 500 sheep have non-uniform fur. So by using the Hardy-weinberg equation, calculate, okay, the first one, the frequency of the recessive allele in the population. Okay, so before we go through the question, okay, apa yang awak perlu tahu adalah, okay, try to analyze first the question. Okay, apa yang ada? What is the information in this question? So kalau awak tengok based on the question, okay, firstly, normal fur is controlled by dominant allele. Okay, capital R. So means that normal fur ni adalah dominant phenotype, while non-uniform fur ni adalah recessive phenotype. Okay, and then in a population of 2,000 sheep, maksudnya di dalam population sheep ni, dia ada sebanyak 2,000 sheep. Okay, that mate randomly. Bila dia mention berkaitan dengan mate randomly, so kalau kita review balik, okay, kita ingat balik, based on the assumption of the Hardy-weinberg, so one of the assumption adalah random mating. So means that this population is follow the Hardy-weinberg assumption. Okay, and then it is found that 500 sheep have non-uniform fur. So means that kita boleh tuliskan dekat sini. So non-uniform fur. Okay, non. Ataupun kita boleh letakkan dekat sini the number. Okay. The number of non-uniform fur. Okay, the number of non-uniform fur here. Number of non-uniform fur sheep is equal to 500. Okay. And then by using the Hardy-weinberg equation, calculate the frequency of the recessive allele in the population. So how to answer this question? Okay, so first of all, macam yang saya dah ceritakan sebelum ni, okay, cara ataupun guideline untuk awak calculate the allele frequency, tak kisahlah sama ada untuk calculate recessive allele frequency ataupun dominant allele frequency, awak mesti kena identify dulu Q square ataupun homozygous recessive genotype frequency in this population. So macam mana kita nak tahu? Okay, so untuk individu yang mana dia adalah non-uniform fur, so non-uniform fur ni adalah homozygous recessive. So non-uniform fur kalau kita ikutkan dari segi dia punya genotype, dia akan jadi R kecil, okay, bilangannya adalah sebanyak 500, okay, over 2,000. Okay, so R kecil di dalam Hardy-weinberg equation, it will be represented by Q square. Sebab apa? R kecil ni adalah homozygous recessive genotype. Okay, so dari segi frekuensi, okay, so maksudnya homozygous recessive genotype frequency di dalam Hardy-weinberg equation, it is represented by Q square. So kita dah dapat lah, okay, the value of the Q square. So apa yang awak perlu tuliskan dekat sini adalah, okay, firstly, you have to write homozygous. Okay, homozygous recessive genotype frequency. Okay, and then you write the comma Q square. So you have to write. Q square ni dia akan represent apa? So mesti kena tulis homozygous recessive genotype frequency, comma Q square equal to 500 over 2,000. So yang saya tuliskan dekat sini tak perlulah tunjuk dalam awak punya cara kerja. So just tulis yang ni saja. Yang ni sebenarnya untuk bagi awak nampak lah. Maksudnya kenapa kita katakan okay 500 untuk dapatkan homozygous recessive genotype frequency ni, kita tengok bergantung kepada the number of the individual which shows the recessive phenotype. Okay, so bila kita dah dapat dalam bentuk macam ni, okay, so untuk dapatkan Q, so Q adalah frequency of recessive allele. Okay, frequency of recessive allele. So based on the Hardy-weinberg equation, so frequency of recessive allele, it is represent by Q. Okay, so awak kena carilah 500 over 2,000 ni sebenarnya adalah 0.25. Okay, so tulislah dulu dekat sini. Okay, Q square equal to 0.25. Okay, so untuk dapatkan frequency of recessive LLQ, so you just find set of 0.25 here. Okay, so you will get the answer. The frequency of the recessive LLQ is equal to 0.5. Okay, so this is the answer for the frequency of the recessive error. Okay, and then for the reminder here, okay, kebiasaannya kadang-kadang ada setengah soalan bila awak buat calculation, awak akan dapat bilangan tempat perpuluhan yang banyak. So macam mana kita nak tentukan the decimal places for the answer? So you have to refer to the number of population in the question. So kalau macam ni, the number of the population is 2,000. So kalau kita ikutkan dari segi decimal places, okay, kalau dia adalah dalam lingkungan 1,000, so kita akan ambil dalam 3 decimal places. Tapi since bila awak calculate, awak terus dapat jawapan yang macam ni, so yang ni tak ada masalah lah. Okay, just in case kalau ada banyak tempat perpuluhan, so kalau dari segi bilangan populationnya adalah 1,000, okay, so kita akan ambil 3 tempat perpuluhan. Okay, and then kalau 100, kalau misalnya dia punya bilangan populationnya adalah 100 ataupun value 100, okay, so awak kena ambil in 2 decimal places. Kalau dia adalah 10,000 and above, okay, so kita kena ambil 4 decimal places. Okay, so this is just for your reminder. Okay, and then for the next question, okay, so the frequency of the dominant allele in the population. So since tadi kita dah dapat, okay, frequency of the recessive allele which is Q equal to 0.5, so tak ada masalah dah untuk kita calculate frequency of the dominant allele in the population. Why? Because just insert, okay, the value tadi in the equation of Hardy-weinberg untuk dapatkan allele frequency which is P plus Q equal to 1. So tadi kita dah dapat nilai Q kan. So maksudnya just tulis saja P plus 0.5 equal to 1. Okay, so to get the dominant, okay, allele frequency. Okay, mesti kena tulis yang ni pun, dominant allele frequency. Okay, so it is, buat comma, P sama dengan 1 minus 0.5. So you will get the value of dominant allele frequency is also 0.5. Okay, and then next, the number of sheep with normal fur in the population. So how to identify, okay, the number of sheep with normal fur in the population? Okay, so firstly, normal fur ni, dia adalah phenotype yang mana this phenotype is dominant. So kalau untuk dominant phenotype, it is represent by, okay, saya tuliskan dekat sini dulu. It is represent by homozygous dominant and also heterozygous. So based on Hardy-weinberg equation, okay, so homozygous dominant genotype frequency, it is represent by P square, Y heterozygous genotype frequency, it is represent by 2P Q. So apa yang awak kena cari untuk dapatkan number of sheep with normal fur? So firstly, you have to find first, okay, the genotype frequency for both homozygous dominant and also heterozygous. And then you have to times with the total number of individu in the population. So apa yang awak perlu buat? Okay, so first kali kita kena cari dulu P square plus 2PQ. Macam ni. Okay, so how to find? Okay, just masukkan sahaja value yang kita dah calculate tadi. So P is equal to 0.5, okay, square plus 2PQ. So tadi kita dah calculate P is 0.5, Q is also 0.5. Okay, and then so you will get 0.25 plus 0.5. So the answer you will get 0.75. Tapi ni bukan jawapan lagi. Because the question wants you to calculate the number of sheep with normal fur. So what you have to do, so number of sheep with normal fur. Okay, so you just time, okay, darabkan, okay, frequency, phenotypic frequency tadi, maksudnya this is we refer as the phenotypic frequency untuk normal fur, yang mana dia akan represent by homozygous dominant, okay, genotype frequency dan juga heterozygous genotype frequency. So awak cuma darabkan saja apa yang kita dah dapat tadi, 0.75 times 2000. So you will get, okay, So you will get 1,500 sheeps, okay, for normal fur. So you have to be alert lah. So secara ringkas dia, apa yang awak kena take note adalah for each of the question, okay, make sure awak kena cari dulu, okay, Q square. Macam ni. Okay, lepas kita dah cari Q square, awak boleh dapatkan frequency of the recessive LLQ like this. Lepas kita dah dapat frequency of the recessive LL, automatically kita akan boleh kira, kita boleh calculate the frequency of the dominant LL, P here. Okay, so lepas tu bila kita dah dapat cari P, bila kita dah dapat cari Q, so there is no problem, okay, to calculate the other genotypic frequency. Okay.